Okay, so now let's take a look at the second problem. So here we're told that Acme Widget Manufacturing produces the Justin Bieber action figure, and what they're told is that demand for the doll is dependent on the price of the doll. So in other words, the higher the price of the doll, the higher the price of P, the greater the value of P, the lower the demand, which makes sense. So as D increases, or rather as price increases, D will decrease. So the maximum price that Acme can charge if it wants to sell any dolls at all would be if we want to set the demand equal to 0, and then we would say 10,000 minus 700p, and then when we solve for the value of p, we would get that 700p is equal to 10,000, and that would give us that p is equal to 100 over 7, which is about equal to 14 and 2/7, which is about, let's say, 28 cents. So if we charge more than $14.28, we're not sell. The demand will be 0. In fact, at $14.28, demand reaches 0. Okay, and that makes sense, that there's a price at which people are no longer going to be interested in buying this thing. Okay, so the total amount now in C that the company will earn, so D represents the number of units sold, so we said that's equal to 10,000 minus 700p, where p is the price. But the total revenue the company will earn is equal to the number of units it sells, which is 10,000 minus 700p, multiplied by the price per unit, which is p times now 10,000 minus 700p. So we're multiplying the cost per unit by the number of units that we sell. And that'll give us the total amount of money that the company will earn from selling these Bieber dolls. Okay, so now we have another expression where we say, well, what if the cost of setting up and running the factory to produce these dolls is equal to $10,000 plus $5 per doll? So what that means is that we need to set up the factory to produce the dolls, set up the manufacturing line, etc. And then for each doll that we sell, it costs us $5. So then the cost of producing these dolls is 10,000 plus $5 times D, the demand, the number of units that we sell. Well, we already know that that's equal to this figure right here, 10,000 minus 700 times P. So when we replace D with this here, then we get this expression, and we end up with 10,000 plus 5 times 10,000, or 50,000, minus 5 times 700p, or minus 3,500p, which in total gives us 60,000 minus 3,500p. So as the price goes up, the number of units that we will sell goes down, and so that means that the total cost of producing that number of units will also go down, which is how we end up with this expression here. So now we have an expression for the total revenues that the company will earn from selling the doll, and also the total cost for producing that doll. So what we're going to be able to do then, which as we said, we're equal to P. Well, let's say 10,000p minus 700p. At our profit, or rather our sales, so we have 10,000p minus 700p. Cost, as we said, was equal to 60,000 minus 3,500p. So now that we have expressions for the revenues generated by the doll and the costs of reducing the doll, we can subtract costs from revenue to get the profit. So in order to do that, we're going to go back. So we have 10,000p minus 700p squared. From that, we're going to subtract our cost. 60,000 minus 3,500p. So here's what we end up with for our total. We end up with a total of negative 700p squared. We're going to get minus negative 3,500p, and that's going to be positive, so we're going to end up with plus 13,500p, and then we subtract 60,000.